welcome back. If I didn't see you yesterday, let me officially welcome you to the spring semester of AP Psych. If I did see you, then hello again. We are going to continue our notes on cognition in Unit 5, which used to be 7. And so today we're going to cover some of the material in Module 34 of your textbook, which is on thinking, concepts, and creativity. Yesterday, Dr. Swope talked to you about concepts, and he talked about concepts in the terms of calling it your raw cognitive material that's in your brain. And so one way that you could think about concepts is it's a mental grouping of similar objects in your mind, or similar events, or similar ideas, or similar people. So, for example, the concept of a chair is something that you can understand, even though there are lots of different kinds of chairs. So you could see a dining room chair, a lazy boy, a dentist chair, a high chair, all look very different and are used in different contexts in different ways. But they all match this concept that we have of a chair, that it's something you sit in, it has laying. Even if we saw a type of chair that we'd never seen before, we might still know it's a chair because we have a concept. We have a mental grouping in our mind of these similar objects. Now, within that, we talked about ways that we organize concepts in our minds. One of the ways that Dr. Swope mentioned was the prototype. So a prototype is sort of like the most common example for a category. It's the one that first comes to mind. And so I like to think of like Family Feud, you know, when they say types of birds, and then if you surveyed 100 random people in the US, they would all more likely say something a little less exotic than an emu or a flamingo. They'd probably say something like a robin, or a cardinal, or a bluebird. Or same thing with dogs. More people would probably, if you said types of dog, they might start with something like a Labrador or a Golden Retriever, and not necessarily a Chihuahua. Now, another way that Dr. Swope didn't mention that we can organize concepts is through using something called hierarchies. This is actually something that I highly recommend using when you're trying to organize information in your mind and remember it. So one of the first times we saw this in this class was when we talked about the nervous system. And we talked about, you know, we had the nervous system at the top, then we had the central nervous system and the peripheral nervous system, and then we broke the peripheral down into the autonomic, and etc. So if you took, for example, my area of expertise, the social sciences, you could break that down into different categories. You have history, but then you have psychology, and you have economics, are all types of social sciences. If you go a level further, then within psychology, you have your main perspectives of psychology that you hopefully should know really well with your hand mnemonic. And those all fall under the branch of psychology. So hierarchies are a way to take a lot of information and try to organize it in a way that's a little bit easier to remember. Right. So at the basic level of a concept hierarchy, you have, let's say we're comparing cars versus trucks, right? So the category that we're going to start with is our basic level. Levels below that, that would fall under that, right, would be what we call a subordinate level. So because it's subordinate to the category above it. So sedans, convertibles, and SUVs are all types of cars. So they are subordinate to the basic level of a car. Or similarly, pickups and semis are types of trucks. So this is the subordinate level of the hierarchy. This is the basic level. And guess what's going to be above that? You guessed it. Superordinate. So subordinate is below, superordinate is above. So what could go here that's above cars and trucks? If you guessed vehicles or automobiles, then you had a good guess. Okay, so now we're going to talk a little bit about problem solving and how we solve problems. So there are some ways that we do this. When we were talking about problem solving in psychology, we're talking about doing things like finding relationships among numbers, symbols, ideas, and words, or arranging information to fit some kind of preconceived structure, or making a series of changes in order to achieve a goal. Those are all types of problem solving. Let's talk about different ways that we use problem solving strategies, different strategies. So the first is called trial and error. And this is when you just try different methods until one works. So that's where the name comes from. So I try this, it doesn't work, so now I'm going to try option B. Oh, option B didn't work, let me try option C until something works. This works best when there aren't that many possible solutions to a problem. So it wouldn't work if there's an infinite number of possibilities because you don't have time to test each one of those out. But if you know it's going to be one of 3 ways to do something, then you can try each of those 3 ways out and figure out what's best. I just finished watching, I got really obsessed over the break with watching cooking videos, and so I was watching the Bon Appetit magazine YouTube channel. They have some great videos, and they had a series on all their cooks got together to cook the perfect pizza. And they had this board that they had a hierarchy on with Post-its, so they would post like a category like cheese, and then they would break it down into what they were looking for, and so they'd say mozzarella, so then they'd say fresh mozzarella or store-bought, and it was a hierarchy. But then once they had that planned out and they had ideas and options to find the perfect pizza, they did some trial and error. So they made they made so many pizzas in these episodes. They must have made like 30 different pizzas where they were trying out different things. So they would test out one type of cheese, or they would test out one set of toppings, and then they would see which one they liked best. So that was trial and error. Now, an algorithm, which Dr. Swope mentioned yesterday, is just a rule or procedure that guarantees solving a particular problem. It is a step-by-step process. So it's like a recipe, right? Or a formula. Those are easy ways to think of algorithms that we use in everyday life. They're more reliable than heuristics, which you remember from Dr. Swope's video are shortcuts, but they take longer. So this falls under what we called formal reasoning instead of informal. So let's say you're trying to answer the question, what is the sum of all of the numbers from 1 to 100? Well, you could use several different types of algorithms to solve this. You could add them one by one, right? That's the longer route, but that's guaranteed to get you the right answer. It just might take some time. So you would add 1 plus 2 equals 3, plus 3 equals 6, plus 4 equals 10, etc. What you could also do a little bit quicker way, which is also a formula, if you're a math person, you might have figured out that 101 times 50 is going to help you solve this because there are 50 pairs of numbers between 1 to 100, and all of the pairs' sums are 101. Now, heuristics, as Dr. Swope mentioned, are shortcuts. We sometimes call them a rule of thumb, right? So a rule of thumb is a little bit faster than an algorithm. It's a shortcut, but it's less accurate, so it's more prone to inaccuracy. You could make a mistake along the way. It's not guaranteeing the right answer to the problem like an algorithm would. An algorithm is going to get you the answer. A heuristic might get you the right answer, but it might also be inaccurate. People use these all the time. For example, when voting, many Americans, they don't actually research every single person on their ballot when they vote. And you might have been given the misconception growing up that like you vote, when you go to vote, there are 2 names on the ballot and you just check a box and that's it, and you put it in a little box. That's not at all what it's like. You get a document that has 20, 30 names on it for all the different offices that are being voted for, that are in local elections, state elections, and, national elections. And so that's a lot of time to devote to, researching all those candidates and all of their positions. Now, that is a more responsible way of voting. Unfortunately, a lot of Americans, they use a heuristic. So they use the shortcut of, well, I'm a registered Democrat, so I'm going to vote for all the Democrats. Or I'm a registered Republican, so I'm just going to vote for all the Republicans, R, or D. Right? And that's very common. So that's one common way that you see heuristics in real life. Here are some other ways. If you and your friends are going out to eat and you're looking for, say you're out of town visiting someone in a place you've never been and you want to find somewhere to eat, you might go drive around dinner time and see what places are busy, right? If they got a lot of cars in the drive-thru or a lot in the parking lot, you can guess that that's a popular restaurant. And so that might help you decide which one to go to. And that's usually a good clue. My husband and I use the drive-thru one all the time. If we are in a new place and we see, because let's be real, not every Chick-fil-A or not every McDonald's or not every whatever is equal. So some places you go, it's not the best McDonald's or whatever, what have you. So when you see a drive-through that's all backed up at lunchtime, then you can guess that's probably the good spot. Another type of problem solving that you actually used yesterday in your brain teasers, if you were successful on the brain teasers, is called insight. Insight is a sudden or novel realization of the solution to a problem. It's the ding light bulb moment, right? So let's say, for example, one of the brain teasers from yesterday was a bunch of word scrambles. And most of us will just kind of stare at the letters, and then it just sort of comes to us sometimes. You know, you're like stared at that first set of letters and you're like, oh, hungry. Next set of letters, oh, family, right? You can't exactly explain how you know it or how it came to you, but it just feels like it just suddenly occurs to you, the answer to the question. So one common example of this is suddenly seeing a cause and effect relationship that you couldn't see before. And so Wolfgang Kohler is a researcher who worked with a chimpanzee named Sultan, and he put Sultan into a caged area where he wanted to see how the chimpanzee would solve a problem of getting to his food. And he watched as Sultan sort of looked around and tried to figure out ways to get to the food, and he saw a moment of insight where the chimpanzee suddenly seemed to have a realization about a cause and effect relationship, and he grabbed these rods and he was able to make his way to the food and get the food to himself and eat. And that was an example of insight. And so remember that psychology, we're studying not just human behavior, but also animal behavior and psychology. And so this applies to animals just as much as humans in some ways. So let's say that I show you these puzzles. Without any context, I'll explain the first one. So let's say I'm going to have some word puzzles here. The first is, this stands for 36 inches in a yard. I wonder how many you will know. So let me put these up here and you can pause the video and see how many of these you can solve. Okay, so pause and see how many of these you can solve.